So I'm going to do this one again, but with the approach of a table. That's how we're going to approach it this time, see if it makes more sense. So I'm going to grab some points here, f of x. I'm just going to make a little table here. I've got the given point, -2, -4. I've got this point right here, which is -1, -3. And I want to become g of x. Okay, so let's look at g of x. G of x has got the point 3, 2 on it. And let's find another one on it. Right there it is, 4, 0. All right, now remember, the way we have to do things, there's a specific order, and the order is Bach. Okay, that is the order. And this might make more sense than looking at it from a functional approach. There's not going to be a b, so the first thing I'm going to worry about is h. Okay, I go from -2 to 3 by doing what? How do I make this change in both of these? It's a +5 situation. That's what it is. Now, we show that by not adding 5 inside, but subtracting 5. So we become g of x is f of x minus 5. That takes care of that. Then we have the a. Now, this is where it gets fun. I know a is negative, and it's a multiplier of y. Those are the things I know. So y was -4, and we're going to become something positive, and I can also get it from initial slope. That's the big deal. So here, because we're counting by halves, we fall 2 and we run 1. So a is -2. That's what a is. So let me apply that. Let me do -2 f's of x minus 5. And I need a table for that, by the way. The table for x minus 5 literally says add 5 to x. So this becomes 3, 4, no effect to y, -4, -3. Now this guy only multiplies y by -2. So we still say 3, 4, but we become +8 and +6. Now, look at our goal. This is our goal. I need this 8 to become a 2, and I need this 6 to become a 0. So now I'm talking about k. And in order for this to happen, k has to be -6, because I need to take away 6 from my y values. So that's going to be the next thing I do after I get this little box out of my way. So I'm doing -2 f's of x minus 5 minus 6. And again, this only changes y. And like, I know tables are confusing and all that stuff, but 8 minus 6 is 2, 6 minus 6 is 0, and I match my goal. So here is the actual function. For some of you, it might make sense to look at points. It's really kind of hard to explain all the stuff going on. But it is what it is, kids. I wish I could make them easier. Repetition is where it's going to be. All right. We're moving on to 13. Identify all the asymptotes, and it is multiple select. So the first thing we're going to do is we're going to look for our vertical asymptotes, and they happen when we divide by 0. So we're going to look at 2x squared minus 6x minus 56. We're going to set it equal to 0. I'm going to pull the 2. I believe that's 28. And I'm going to factor. 28 is 7 times 4, I think. I want to be -3. I'm going to use zero product property. X is 7 or X is -4. And these are your vertical asymptotes, okay? The next thing I'm going to do is I'm going to find the other asymptote by long division. Long division always works. Always works. Always. So the dividend is 2x squared minus 6x minus 56, and the divisor, I did that entirely wrong, forgive me. The dividend is x squared plus 2. The divisor is 2x squared minus 6x minus 56. Now, I want this guy to become that guy. I do that by multiplying by a half. So I'd have x squared minus 3x minus 28, and I could do some subtraction. These are gone. 0 minus 3 is 3x, and then 2 minus a negative 28 is 30. And I cannot make an x squared become an x, so this is where I'm at. I have a horizontal asymptote at y equals 1/2. And there's my third asymptote. That's all of it. All right, so on to 14. I want to say that 3 of you got 14 right on the last one, maybe 4. It was pretty bad. It was. What does she mean by that? Sorry, my wife is texting me at the same time, kids. All right, so what I noticed last time, and this was the common mistake, is that about 3 or 4 of you would say like negative x to the 4th is negative x to the 4th. It's not. A negative times a negative times a negative times a negative is positive. If you take a negative and you raise it to an even power, it's going to be positive. So you got to be careful on that. Like that's what killed some of y'all. Anyways, here's the equation. It's 2x to the 6th. We're going to check this. What is f of negative x? It's 2 times a negative x to the 6th minus 2 times a negative x to the 4th plus 2. Now, if I take a negative and I raise it to an even power, it becomes positive. Same thing here, it becomes positive. Notice I'm not distributing a negative times a negative, I'm focusing on this, and then plus 2. So what do I have here? I have the same thing. So I'm even because f of negative x is the same as f of x. Good to go, Joe. All right, moving forward. 15, restrict the domains that f of x is 1 to 1 and find the inverse of g of x. And it should say g of x is 1 to 1. State the domain of g of x and its inverse. So, anyways, think about your graph. Right 5, up 3. And it's got the x squared component, so here she is. I throw away this piece. Right? So my domain is from 5 to infinity. And that's going to be the domain of both pieces. Because in order to write the inverse, this has to be true. So it is the domain of both. It is. It's just the way it works. All right. Now let's go through our inverse process. Step 1, we swap x and y. In this case, we're going to get that g out. X is 2. There's an x, becomes a y. Minus 5 squared plus 3. And then we're going to do things in the order we were taught from grade school on up. We're at step 2 now, by the way. Solve for y. We're going to take that 3 and we're going to move it over. X minus 3 is twice y minus 5 squared. Now we're going to counteract the multiplication with division. X minus 3 over a 2 is y minus a 5 that is squared. And now we're going to counteract the squaring component by taking the square roots of both sides. And the reason we don't use plus or minus here is because we restricted this to an increasing range, or increasing domain. Yeah, increasing range. So we end up with the root of x minus 3 over 2 is y minus 5. And now we're going to move that 5 over to the left-hand side. We're going to change subtraction to addition. And we're going to replace y with the correct notation, the inverse. And that's what we end up with. All right, now state the domain and the range. It's a little harder to think about the shifts that are going on this one, but this is literally an up 5 situation. It's going to go right something. I don't know what it's going to go right. It's going to go right something. Pull the half. It's actually going to go right 3. We have 1/2 x minus 6. Yeah. But anyways, it's going to go right 3, and the most important thing is it's going to go up 5. And then it's going to be the arm again. But this plus 5 is always your range. Your range is 5 to infinity. That's how that works on square root functions. And then we have one more to go. Number 16. Let f of x be 1 over x plus 7 and g of x be 3 over 2x minus 7. Find, I don't know where this went, but the domain of f of g of x. Yeah. All right. So everywhere I see an x, I'm going to become this. So that's going to become 3 over 2x. Then I have minus a 7 plus a 7. Oh, that worked out nicely. Let's make this a different number. Make that minus 9. I need to change that. Anyways, cleaning up a little bit here, I get 1 over 3 over 2x minus 9 plus 7 minus 2. All right, here's some things I know. I'm going to focus on this. That's a divisor. So I know that 2x shall not be 0. So x cannot be 0. I also know that 3 over 2x minus 2 cannot be 0. I'm going to add 2 to both sides. 3 over 2x cannot be 2. I'm going to counteract division through multiplication. So 3 cannot be 4x. X cannot be 3/4. There's my 2 restrictions. So what am I allowed to be? I'm allowed to be anything from negative infinity all the way to 0, anything between 0 and 3/4, and anything from 3/4 moving right to infinity. So there's my true domain. All right, part 2. Find f of g of x such that is a unified fraction. So we're going to take this guy right here. And we're going to multiply it by the LCD, which is 2x. We're going to 2x every single piece. 2x times 1 is 2x. Think about this. 2x times 3 over 2x. The 2x's cancel. And then 2x times -2 minus 4x. And by the way, you know, if you didn't understand this, like if this was just gibberish, like, ugh, right? You can take your 3 minus 4x and you can say it's not 0. Add 4x to both sides, and you still get that x is not 3/4. So you can do that there too. Just saying. You can do a little bit in the beginning, and then you can finish it off at the end. And there you go, kids. That is the last part of the basics. I hope you guys do wonderful on the next one.